Welcome, Earth Science folks, to our little podcast about volume. Volume is really important for us in Earth Science, mostly because it's going to help us to determine densities of objects later on. So without any further ado, let's get to volume. Volume is simply the amount of space occupied by an object. For example, I have this cylinder full of my kid's blocks from when she was little, and so this object occupies space, and that space that it occupies is called its volume, okay? Volume is almost always used to measure liquids. You could use mass to measure the mass of the liquid, or if you had the liquid in some kind of a tube or something, you could measure how high it was in the tube, but we don't normally do that a whole lot. Normally we measure the volume that the liquid takes up. And of course you can always measure the volume of some kind of solid object like this block. You can measure how much space this takes up as well. Okay, the units we use in volume are almost always need my pen, excuse me, are almost always liters and milliliters. We think of these as typically used with liquids, but you can use them with solids if you're taking a volume measurement, but normally we use other units for solids. For example, if it's a big object, we might use a cubic meter, or if it's a little object like this little guy, we would probably use cubic centimeters. Because we'd be using length type, we'd be taking length times width times height, and that would give us centimeters cubed. But in all honesty, 1 milliliter equals 1 centimeter cubed, so they're kind of interchangeable. All right. Now, volume can be measured in two ways depending on how the object is shaped. Okay? If the object has a regular shape like this, regular straight size, you can use a ruler and measure its length times its width times its height, multiply those together, and you will get its volume in cubic centimeters if it's something this small. But if you have an object, I don't know, let's say this little funky object, or hold on just one moment, please. Let's say you've got this funky object. You probably can't even see this, but it's a fossil of a snail, and that has definitely not got straight sides, okay? In that case, you would need to use a method we call the water displacement method, and this is really useful and important to us to use, okay? All you would do in the water displacement method is you would put some water into a graduated cylinder, okay, or some sort of cylinder with the measurements of milliliters marked on it. Place the object, and you would measure, put some water in, enough to cover this object, but don't put the object in yet. Put the water in, measure how much water's in there, 10 milliliters, whatever. Then you drop in your object and you measure how much the water went up. Okay, so let's look at a possible example. Whoops. Okay, if we have the world's tiniest dinosaur right there, and we have a graduated cylinder with water filled up to the 2, 4, 6, 8, 10, so 4.8 milliliters of water, okay? And we take this world's tiniest dinosaur and drop him in, and the water level rises up to the level of 5.6 milliliters of water. So how much volume does the world's tiniest dinosaur take up? Well, 5.6 minus 4.8, okay, is 0.8 milliliters, or 0.8 of a milliliter. So the world's tiniest dinosaur is pretty darn tiny. Okay, so that would be the volume of that dinosaur. All right, so that is a very short little talk about volume. Our next little talk will be about density. See you next time. Thanks for watching.